Hey y'all, coming at you with the third translation or transformation we're going to talk about today. We talked about translations, we talked about reflections. Now let's talk about rotations. Rotations are what we would say is the last rigid transformation we're going to talk about, which we'll talk a little bit about what that means. But basically, a rotation is a turn or a twist, right? Now, the good news for you guys is we don't necessarily have to learn the rules for where those new points are going to be. Um, what's really cool is like on the air test, usually we have like paper that you can just trace and then you can actually rotate it. So it'll kind of help you figure out like if you need to, where it would be. But really, we just need to be able to recognize a rotation and describe a rotation. So those are kind of the two things. Most important thing here, and this is what I meant by the rigid transformation, is that rotations are always congruent. Just like we talked about with the other two, these are going to end with shapes that are congruent to the original shape. Really, it's going to be the same shape and size and all that stuff. It's just turned. It's a different orientation, if you want to think of it that way. And they're going to be the same. We're going to have congruent shapes. So let me kind of show you an example of what we're talking about here. Let's say we had a graph. And I'm going to use a right triangle. And there's a couple of things that we just need to talk about. Cool. And in case you know, that's pretty tiny Tim. We'll call it ABC. And A is at 2, 3. And B is at 5, 1. And C is at 2, 1. Cool. So when we have a rotation, like I said, we're not going to actually change the integrity of the triangle. We're just going to turn it to a new location. And there's basically some things that we need to talk about when we talk about rotations. So rotation, we need to talk about degrees. We need to talk about direction. And we need to talk about axis of rotation. Like I said, 3 things. 3 that we need to talk about when we do rotations. All right? So degrees are how many degrees we're going to actually turn this shape. Now, typically for us, since we're kind of the intro level here, you only have 3 options. We can go 90 degrees, which is a quarter turn. We can do 180 degrees, which is a half turn, or we can do 270 degrees, which is 3/4 of a turn, right? So basically, you know, are we turning it just a quarter? Are we turning it halfway? Or are we turning it 3/4? Notice that 0 is not a rotation because it would just be where it is right now. Same with 360, right? We don't rotate 360 because it's just where you started at in the first place. So that's not really a rotation. It just stays right there. Direction. I wish I would have spaced these out a little bit more. Direction. You have 2 options. Is it clockwise or is it counterclockwise? which way are you going? If you're turning this way, like a clock turns, then you're rotating it clockwise. If you go the other way, right, this way, that would be counterclockwise. And notice some really interesting things. 90 degrees clockwise, 1/4 turn clockwise, is the same thing as 3/4 turn counterclockwise. So 90 clockwise is the same as 270 counterclockwise, which is why it's important that you state which way you're going. If you just say I rotate 270 degrees, that doesn't really help anybody anyway, because you don't know which way you're going 270 degrees. The axis of rotation is the hardest part for some reason. Rotation. Let me write it back up here. So what are you spinning around? In Sunday school when I was little, we used to make like paper plates, and you cut part of it out, and then you could spin it. And we use those little things called a brad. It's like brass, and you poke it through the middle and turn out the outsides, and it would spin. That is the perfect example of an axis of rotation, right? Or if you're a basketball player and you have a pivot foot, right? That pivot foot is your axis of rotation. So there's one thing that we're going to turn around. What is that one thing? So it could be a point. For example, we could spin this thing around point C, and that would be our axis of rotation. We just put that little brad right there and then turn this thing, and it would still be on point C. Is it around the origin? Which would be 0, 0, right? That's like if we make this thing a pinwheel and we stick the brad right in the middle here, the whole section is going to move. That would be the axis of rotation if it was the origin there. Or the third option is the center of the shape. Center of the shape. So is it the center of our triangle? Are we spinning the triangle around itself? That would be more of like a ninja star, right? We're spinning it around itself, or a pinwheel, I guess, if you want to think of it that way. So you guys will just have to kind of look at the pictures or see what they want you to do. And these are the things that are going to be important. How many degrees? What kind of direction? What's the axis of rotation? So let's say I was going 90 degrees clockwise, and we went around point C. So the key with if it has a point is that it will still share that point no matter what. Here's what I'm talking about here. If we rotate around point C, let's go 90 degrees, so it's only a 1/4 of a turn. And I just kind of am going to move these points. So this was 5, so we're going to go 5 down from here. 1, 2, 3, 4, 5. Wait. Oh, it's only 3 long. My bad. So like this. This would be, if we spun this point around point C, right? We literally just turn this thing. This would be A prime. And this would be B prime. And notice that that kind of helps us to see how many degrees. If B prime was facing that way, it's like a compass. Now, or I'm sorry, B is facing that way. Now B prime is facing this way. It only moved 90 degrees in here. So that's what it would look like if we rotated around point C. That's a 90-degree rotation clockwise around C. Let's say I rotated it around. We won't do the center of the shape because that's a little bit too hard to see. But I think that one makes sense to you guys. Hopefully it does anyway. Let's say we went around the origin, which is pretty popular also. Now we're going to move this whole quadrant and we're going to rotate it all down. Right? So it was here. Now we're just going to rotate it 90 degrees this way. So this point now turns into this point. And then we just kind of look at what's going on. So my triangle was 2 length here. So that's going to be 2 length here. And then over here it was 3 length. So we're going to go down 1, 2, 3. Not my best picture, but that's the same idea. So now you can see that C prime is here, A prime is here, and B prime is still facing downwards. But now they're not sharing point C. So if they share the point, then you can bet that you rotated around the point. If they don't, the likely guess would be that they went around the origin. But it could go, like I said, around something else too. Those are the 3 big ones. How many degrees? What direction? What's your axis? And you guys will kind of practice with those a little bit in your workbook page today. And then tomorrow you get to play with those a little bit and actually look at what it looks like when this thing rotates. So hopefully that'll help you guys out. All right, cool. So that's rotations. Those are the 3. Those are the only ones that are going to give you congruent shapes. Reflections, translations, rotations. We're going to talk about more, but they are not going to be rigid, which means they're not going to hold their shape and be completely congruent to each other. Some things are going to change about the shape, and that's going to kind of throw stuff off a little bit. But that's going to be important as we continue to learn about those. All right, cool. Activity tomorrow. You guys have a nice long weekend. I'll catch you guys on the flip side.